Hi, and welcome to Solving Systems, a quick review of graphing in this video. So we'll look at a few situations where we can graph to find solutions. So let's zoom in on this first one. Notice it's going to be best when these are already ready to graph. So we got a situation here where both of those are in slope-intercept form and ready to go. So let's do the two equations. So this first one will be the red equation. Y equals 1/2 x plus 4. So we'll start at our 0, 4, our y-intercept, and we're going to use our slope 1/2. 1 tells us to go up 1, and 2 on the bottom tells us to go right 2. So up 1, right 2. Graphing just as we have before. Now flip the script and go the other way. Down 1 and left 2. Down 1 and left 2. Left 2. Left 2. Okay. Remember the first one, you're going to want to dot the whole thing because it's going to be easier to match up your solution to where it is when you have the entire graph mapped up. I know it's not a perfect, the line doesn't perfectly go on the dots, but you get the picture there. We can adjust it a little bit. Let's look at the other one. It's called the blue line. So we got a situation here where our y-intercept is going to be at the point 0, -4. So that's going to be down here. Now our slope, notice the negative sign here. I always like putting it up top first. -7 over 2. Now a -7 on top tells us that we're going to go down 7. And a 2 on bottom tells us we're going to go right 2. Now if you notice here, if we go down 7, we're going off the charts. Okay, so we can estimate about where it's going to be, but just know that that's an unofficial point here. So what you're going to want to do is you're going to want to flip the script. Instead of going down 7 and right 2, think about going up 7 and left 2. So now when you do this and you go up 7, so let's just up 7, 1, 2, 3, 4, 5, 6, 7, and left 2, you can see how that nice and neatly lands on that spot. And we'll do it again just for good measure. 1, 2, 3, 4, 5, 6, 7, and left 2. So we can see the line that is formed as we do this. And more importantly, we can see where these cross. And if we look at that, we can say that, all right, this point is going to be 2 to the left, so it's going to be -2, comma, +3. Whoops, -2, +3. So what would happen if we were to type these into the equations just to double check to see if they come out correctly? So we're going to go 1/2 times -2 plus 4, and this should come out as 3, which it does. And now let's plug in -2 for the other one. So I got -7/2 times -2 minus 4, and we see that this should come out as 3 as well, which it does. So we know that it checks out in both cases. So that's how you can check these. You plug them back in as we've talked about throughout this unit. So let's look at a couple more situations. So here we've got 7x plus 4. We'll call this our purple equation. We've got that. Our slope is going to be 7, so 7 over 1. It's going to be up 7, right 1. So we're going to go up 7, right 1. This is going to be off the chart, so that's our unofficial point. Now, flip the script. Let's go down 7 and left 1. 1, 2, 3, 4, 5, 6, 7, and left 1. And then down another 7 and left another 1. And we see that this is our line, which is great. Okay. Let's look at the other one. We'll call this the brown equation. So I got y equals 7x minus 5. Y is at 0, -5. And there's that. Our slope is the same as it was before. Wait a minute. 7 over 1. Same slope, different y-intercept. 1, 2, 3, 4, 5, 6, 7. Think back to when we were doing this. Well, these are going to be parallel. These lines are going to be parallel, telling us that there's going to be no solution when it comes down to it. So this is going to be no solution. These will never cross. You could have looked at the equation right away and tipped off by the slope, but you know you look at the distance between the 2 points here, and then that. And then that is, just know that that is going to be consistent throughout the entire thing. So this distance between points is always going to be there as you work your way through. So those are parallel, no solution. One last one to take a look at here. We've got, we'll call this the black equation. So we've got negative 4x minus 9. So my slope is going to be negative 4 over 1. Remember, anytime you've got a number like that, you can write it over 1. And that negative is going to stay up top. So this is going to tell me to go down 4 and right 1. So for the black one, we're looking at a y-intercept of negative 9. So 0, negative 9. This is where my slope is going to be. If I went down 4, notice I'd be off the charts. So we're not going to do that. We're going to flip the script, though, and we're going to say, all right, instead of going down and right, we're going to go up and left. So we're going to go up 4, 1, 2, 3, 4, and we're going to go left 1. And just continue on for the length of the graph. 1, 2, 3, 4, left 1. 1, 2, 3, 4, left 1. 1, 2, 3, 4, left 1. Okay, and here we go. We have our line. There's our line for the first one. Let's do a pink one. So we've got the pink equation. Notice that it's just a negative sign. Well, that's like saying negative 1 out in front. So we're going to go down 1 and right 1. So we're going to start at our y-intercept of positive 3. So we're going to go to 0, positive 3. And we're going to go down 1, right 1. Notice we're not really making any headway here towards that line. We're actually going in the opposite direction. So let's flip it around. And instead of going down and right, let's go up and left. So starting back here, we're going to go up 1, left 1. There, that's more like it. Now we're getting closer to that line. You can see where those points converge on this graph here. And that is the location of the point is going to end up being, let's see, it is at negative 4 and 7. So the solution to this one is going to be negative 4, comma, 7. And what should end up happening when you plug these in to the original equations there is they should come out with true statements. So that's a quick review of solving